Welcome. Okay, let's dive into this explainer. Today, we're looking at a truly fascinating, kind of rebellious approach to building software. We're going to explore the journey of developer Nelson Rojas Nunez. You see, he set out on a very specific quest to build a sustainable, resilient software framework that completely rethinks how we handle web requests. It's a question a lot of us are asking right now, isn't it? Has modern web development just become way too complicated? Well, Nelson felt exactly that way. For years, he was right there behind the keyboard, adopting all the best practices, trying to avoid the classic mistakes of whatever programming language happened to be trending that week. But eventually, complexity fatigue set in. He found himself just getting bored, hammering away at the keyboard with the exact same heavy, bloated tools day in and day out. He was looking for a spark, something that wasn't just another shiny code generator, but something fundamentally easy to follow. Now, what's really interesting about this slide is how this approach strips away all the magic and, honestly, the marketing of modern tech. Nelson took a step back, took a deep breath, and boiled development down to this one simple truth. Everything we do is nothing more than processing text. If you come from a Unix background, this philosophy makes perfect sense. It's a radical return to basics. By remembering that, at the end of the day, a server is literally just receiving text and sending text back, it sparked an incredibly simple idea. This realization led to Section 1, the Napkin Blueprint, a visual architecture so incredibly lightweight it almost defies modern conventions. Think about that for a second. An entire web framework designed to fit on a paper napkin. That is the central metaphor of the Parina Framework. But the goal here wasn't just to be small for the sake of being small. The goal was to create an architecture so profoundly simple that any developer, no matter their experience level, could hold the entire blueprint in their head at one time. No massive documentation files needed just to understand the basic data flow. But hey, don't let the napkin metaphor fool you into thinking this is just some toy. Nelson was deeply inspired by rigorous training, specifically a Secure Code Warrior course. So despite its miniature size, the blueprint had to strictly adhere to incredibly high standards. We're talking highly secure, built with top-quality code, fully testable, and completely understandable and extensible. I mean, that is a massive list of constraints for something you could literally sketch out at a coffee shop. To make all of this fit together under those strict constraints, we arrive at Section 2, guards, doors, and routing. Let's look at how the backend traffic actually flows. So the very first step in the framework is the front controller. While it sounds like a really fancy architectural term, it's honestly just a request concentrator. It basically tells the server to take absolutely all incoming traffic and route it to a single file, a simple index.php. All traffic gets funneled to this one entry point, which keeps the initial routing strictly and cleanly organized. And this brilliantly illustrates how security works in Parina through middleware. Nelson describes this as the palace guard, or if you're hungry, think of it as the patty in a sandwich. You simply cannot reach the other side of the bread without getting past the patty. This middleware reviews the request, runs validations, and neutralizes any attack vectors. If a request is bad, it gets stopped instantly, right there at the door to save CPU. We can actually see this in action by contrasting two simple routing scenarios. If a user comes to door A via a simple GET request that doesn't need any security, the framework sets zero obstacles. It just hands them a map to their destination. But if someone comes to door B, a secure route, they have to get past that palace guard. They must present a golden ticket with a specific password like Wonka to proceed. If they don't have it, no way, they don't get in. Now, if you do get past the guards, you reach the handler. This heavily emphasizes the S in the solid principles of software design, single responsibility. The handler has exactly one job and one method. It receives the request, processes it, and generates a text response. That is it. The whole shebang is simplified to the absolute extreme. When you put all of those pieces together, you get this beautiful, linear sequence. The Parina request lifecycle is incredibly strict. A request enters, hits the front controller, passes through any optional middleware guards, goes to the handler, and outputs a response. This sequential flow is exactly why it fits on a napkin. It's so mentally easy to digest for any developer jumping into the codebase. Section 3, contracts for extensibility. Let's move to and see how this builds into something robust enough for professional use without losing that napkin-level simplicity. The secret sauce to keeping Parina professional and standardized actually lies in interfaces. Think of an interface as a blueprint featuring strict contracts. It forces standardization and what programmers call polymorphism. In plain English, That simply means you can create absolutely any flavor of response you want, JSON, HTML, plain text, whatever, as long as it fulfills the interface contract. It keeps the framework completely extensible while enforcing strict rules. So the crucial point here is how this architecture handles failure. If that palace guard we talked about earlier decides you don't meet the conditions, the request is discarded instantly. In one fell swoop, without looking back, the request and its history are lost in time. By dropping these bad requests immediately rather than processing them further, the framework avoids unnecessary CPU overhead. And that prepares us for a rather shocking performance reveal. Because this extreme simplicity isn't just an aesthetic choice by a bored developer. It brings us to Section 4, Tech for the Forgotten. By designing an ultra-fast request and response cycle, Nelson created a framework uniquely suited for highly constrained technological environments. Parina presents a true inclusion strategy. It deliberately empowers developers and end users who are working with limited resources, the folks who just cannot afford the massive server costs required by modern heavy web frameworks. To understand just how lightweight this is, look at this number, 40 kilobytes. That is the ridiculously low memory footprint of this framework. When you contrast that with the megabytes, or let's be real, gigabytes of memory demanded by modern bloated web tools, 40 KB is almost invisible. It's practically nothing. And the results of this tiny footprint are absolutely staggering. Nelson ran a stress test using a machine from the year 2003. Let that sink in for a second. A 2003 Celeron processor with just 512 megabytes of RAM. On that incredibly old, low-spec machine, a server running the Parina Framework was able to respond to more than 200 requests per second. It turns out you absolutely don't need a cutting-edge cloud server to run a high-performance web application if your foundation is built right. Which brings us to the core mission of Parina. Nelson realized that because of the incredibly few resources it required, Parina could become, in his own words, a tool for the forgotten people of the industry, for communities with slow internet access or with computers over 15 years old. This framework is a vehicle for digital inclusivity. It's bringing high-quality software development to those who have been left entirely behind by the escalating hardware demands of the modern tech industry. Which leaves us with a critical thought to ponder. We spend so much time chasing the latest, heaviest, most complex tools. But when we choose those bloated frameworks, who are we excluding? Is the software you build truly accessible to everyone, regardless of their hardware or their internet connection? The Parina Framework proves that by simplifying our approach to fit on a paper napkin, we can build software that is fast, secure, and above all, radically inclusive. Thank you for joining me on this explainer, and I'll catch you next time.